This was the when the both the temperature are at the same uh, both the walls are at the same temperature. This is the temperature distribution with heat generation. This is one of the things. Now with this, what is the maximum temperature is important. This is T of X, is it not? Where is the maximum temperature and what is the maximum temperature is important, right? So what is the maximum temperature? Okay. See, the variation, this is evening class, right? Date 20, sorry, 14 November 2020, right? And this was started, we started from here today, right? From here. So this was 14th November morning class, right? So that's just for my reference, I'm sure. This is the evening class, okay? Evening class, okay? The uh, the variation of temperature in the above equation is parabolic, is parabolic, right? And symmetric symmetric about the center plane, about the center plane with maximum T max, maximum T max at x is equal to b by 2, correct me? How did you get that? B by 2, how do you get that? This can be obtained by by differentiating by differentiating equation 7b, 7b, that is dt by dx is equal to minus qg by 2k into b square into 1 by b minus 2x by b square is equal to 0. Oh, ಮಾಡಿದೆ. Start ಮಾಡಿದೆ ಆಯ್ತಾ? This implies that 2x by b square is equal to 1 by b, or x is equal to b by. Makes sense? This is when both sides are equal. So anything can be derived. This is just an example I'm giving you. Don't remember these things. Only get the way we have done. Always understand to solve the differential equation. It does not take much time. And whatever gate problems comes basis on solution of this. Don't remember this one and say, so it should be like that. Just have a memory saying that okay, this can be done like this. Just like how you remember problems. Like that you have to remember this. Okay. Done. Next. What is the maximum? Ah, say today you see the number of pages are big. Number of pages we have completed is too much, is it not, into morning classes? But then the load on the mind is less. Are you seeing that? There's no much load on the mind. Everything is clear cut. Okay, similar thing happens when you learn these things also. Only the pages are big. You can boast to some of your juniors that see how difficult it is. All differential equations. Like we used to do when we went to fifth standard. If our brothers are in the third or the second standard, we used to say, when you go to fifth standard, we have to write so much. And so teacher will say very fast, we have to write fast. Don't be boast. It's common thing, is it not? So only for that purpose this is there. Okay. Sure. Done. So now, what is a T max? Okay, substituting x is equal to b by 2 in equation 7b, we obtain the maximum temperature. Write it along with me, students. T max. So T max is equal to minus qg by 2k into x square. Okay, sorry, into b square, into x's b by 2b minus b by 2b the whole square plus t1, correct? So this would come as equal to t1. This comes as this whole thing, see, b square by 2b. So what happens? bb cancels, so 1 by 2 square, this bb cancels, 1 by 2 1 by 2, so it is minus qg by 2k b square into here 1 by 2 minus 1 by 4, correct? What is 1 by 2 minus 1 by 4? 1 by 4. So 1 by 4, and then which is higher? The higher is 1 by 2. 1 by 4 is lesser, right? So we get, sorry, there's a mistake there. 2x by b square. I'm sorry. Here we have to write 2, yeah, no issue, no issues. X by b square, right? So here b by b square, that is 8, correct? Okay. So there is some mistake. Which is higher, dear? 1 by 2 is here. There is a minus here. Okay. So minus is there, fine. I can do one thing, that this can we take the other way around? 1 by 2 minus 1 by 4. 8, 8. Can we do 1 by 4 minus 1 by 2? Minus outside. So let us take minus inside. So what is it? QG. Then you will get minus again. Is it? You cannot do that. Minus of x by b square. B by 2 square, right? B cancels. There is a minus here. Somewhere we have done a mistake. X by b whole square. There's a mistake, student, somewhere. So you get a minus. There's a mistake in the differential equation. Minus. This should be plus. This should be plus. No, it should not be plus. Which is positive? Okay, let us do here. Where is a mistake here? We will see.
Positive, the other one should be negative. Presently, your term is x square term are getting us.
X square term is over here. Should be negative. Oh, yeah. This is a mistake in the book only. This is a mistake in the book only. So what will happen? You write this as positive, this as negative. It should be x by b the whole square minus x by b. Correct this, students? This should be equal to minus qg, or I'll write here Tx should be equal to minus Qg, or we'll do one. We'll not worry about this. Make this plus. Done. Problem solved. Problem solved. Make that plus. Solve. Correct? So then this would be plus. Mistake. Mistake is mistake. Whether Nag does it or Ananth does it, it's the same. Or Ananth Nag does it. Whether Nag does it, Ananth does it, or Ananth Nag does it, mistake is mistake. Yeah. Done. Now, this would become plus then. This would go as Qg b square by 2k, and here you'll have 8k, is it not? 8k plus T1. Very important. This is the T max. Better you remember this, students. This is to be remembered, okay? Because it's easier to remember and is asked a number of times. This you remember it. Remember. Not because it's important, but it's easier to remember. Qg b square by 8k plus T. When both sides are same. Very important. Mistake in Nag. Maybe in the later versions, yes, correct. Location of heat generation, the whole slab is generating heat. It is like if current is passed through, generation of heat is happening. You get? No, it's per unit volume. Hmm. Qg is what? Qg is what? Here. Correct? No. Per unit volume. Okay. So I hope you got the same. Actually, no? That shows that our correct calculation is proper. Uh, simple layman will also say ಎಲ್ಲಿದೆ ಜಾಸ್ತಿ ಟೆಂಪರೇಚರ್ ಬಿಸಿ ಎಲ್ಲಿದೆ ಜಾಸ್ತಿ ಮಧ್ಯದಲ್ಲಿದೆ ಸರ್ ಹೇಳ್ತಾರೋ ಇಲ್ಲಿ that's what. So what is engineering is what the layman says, we put it in equations. Simple things it should prove. Complex things what layman cannot prove, we will prove. But what layman says, whatever is his experience in general, that has to be correct. Which one? Because heat is generated inside. I'll repeat. See here, have you written this down? No. Done? Okay. So now what is happening here is, see, this is the slab. Let us take this is the slab. And heat is generated inside. Everywhere, every molecule is generating heat. So what will happen? Here it is T1, here it is T1. So how the profile is, it is like this. Where is the maximum? The profile is like this, is it not? Where is the maximum? At this is B. This is B1. And what is this? What is this distance? This distance is Qg B square by 8A. Intuitively got it?
It reduces so that the
Which reduces. We are maintaining at T1. There is heat transfer happening. Maybe something is taking out the heat. Heat is generated. It's a steady state. If it is a steady state, Whatever heat is generated, it is being removed. If it is not being removed, it is not a steady state. What is happening? Temperature is increasing. Huh? Because maybe we have there is some chemical reaction going on, or maybe electricity is passed through that, or maybe some other things. Maybe combustion is happening inside. There is a core which is burning. Maybe a nuclear. It's a nuclear. What is a rod where fission reaction is happening. That's also one of the reasons. Or any chemical reaction is happening, or maybe inside the rod there is petrol which is burning, or maybe rocket is a rocket engine, inside it is combustion which is happening. Various reasons. This slab may be a part of, or this is not a that's a cylinder, let form. You may have a cylinder where it is actually the cylinder is the center of the Brayton, how to say, center of the gas turbine or the engine of the plane, where combustion is happening in a continuous rate. You understand? So generation of heat is happening. Fair enough. You got the point where and all it is applied. Or maybe it's your silencer where the hot flue gases is going out. So heat is generated inside, and from there in the sense generator only it will come. Is it not? Heat is coming inside. If you take it as a control volume, it's a different case. If you take conduction, you have to take it as a generation only inside. Starts from the core. Not that it starts from the core. Every molecule is burning there. Every molecule is generating heat there. No, heat generated there. Heat generated, again I will tell you, it's like, say, current is passing. Maybe you are inserted a hot rod into the, not rod, electrical rod. You know, boiler. You have that dip rod. You know, electricity rod, which electric heater, rod heaters. You dip that electric rod inside. So what is happening? It is generating heat. How it is generating heat? Electricity is passed through that. So every molecule in that will generate heat because electricity is passing. What type of thing is done when electricity passes? It's electrical work which is done on the system. So if you consider thermodynamics, that will come in W. Exactly. That's why it is work. So electricity pass is electrical work done on the system. Make sense? Integration of Q, cyclic integration of Q is equal to cyclic integration of W. Or Q minus W is equal to change in internal energy. Here you should not take electrical work done as a Q, it should take it as W. If you take in W in the first law, only then the things will go proper. Otherwise, it will not. Make sense? That's how it works. Make sense? So next. So it's important that you understand it better. But in reality, what happens is, um, see, in reality, generally, okay. Now, if I consider dimensionless form, first we will go with dimensionless form, then we will go with reality. Why dimensionless? I will tell you later. Okay? So, in the dimensionless form, in the dimensionless form, equation 7b, equation 7b, 7b, equation 7b, 7b. Uh, okay, 7b, equation 7b can be written as T of x minus T1 divided by T max minus T2 is equal to 4 times zeta minus zeta square. This you write it as equation number. This you write it as equation number 8 is over, right? 9. 8 is over, right? 9. Where zeta is equal to x by b. Zeta is equal to x by b. Derivation is homework. I do the derivation. You'll do it. Want to do it? I'll do it. Okay. It's homework. It's easy. It's just some algebra you have to do. Okay. So that you can do. You put p x, you will get it. Okay. If you don't get it, then tell me. Okay. Now, this is how the heat generation takes into picture. Now let us take another point. Then write this down first. If you want, leave some space for derivation. From now, this is what in IIT they do. If you have an algebraic expression to be done, man, you do it. Because that is simply a waste of time. The concepts only has to be. You should not waste time on redundant things, which you can obviously do. When you came initially, I used to do every point. Why? To make you comfortable. Now what is happening? Since you are comfortable now, and you will feel this. If I do all these things now, you will feel it's a drag on time. Don't you feel so? This is a drag on time. Yes or no?
It's little faster.
Once.
To divide on anything.
So that's it. Okay. But when the transition is happening, I have to be careful. I have to tell that this transition is happening, so you have to understand. Huh? Done. Bharat, done. Next. Now, let us say case 3. Case 2 is over. Case 3. One-dimensional heat conduction through the slab with heat heat generation and convection at two ends. Convection at two ends. So we are going to combine convection as well as convection. So what is the way is, see, I have a slab here. The way we do is, this is a slab. Now there is heat generation which is happening. And here there is convection. There is boundary layer, everything is there. So let us say this is T infinity of the surrounding air. Fine. The fluid may be going like this. Okay. This is the direction in which the fluid is moving. We are not worried about which direction the fluid is moving. Okay. We are direction only on this side we are worried. Okay. Let it be moving. Okay. Let it be there. Okay. This side we are not worried. Okay. That side we are not worried. Okay. Okay. Fine. I hope you got the point. Now here, what happens here is, so T infinity is over here. Here T infinity. So if I draw a line like this, how is the variation? General expectations, it's a parabola. This is a general expectation. With this being T wall and this being T wall, same temperature. Expectation, it will come like that only, don't worry. There is no counterintuitive thing here. So this is the variation of temperature. Fine. So now let us say what is the equation in one dimension. In one dimension, heat conduction equation. Heat conduction equation reduces to heat conduction equation reduces to d square t by dx square plus qg by k is equal to 0. Of course, steady state, right? Steady state. We are considering steady state only. Okay. Now, let the excess temperature at any x, be theta is the excess temperature. Theta is equal to T minus T infinity. Differentiating, differentiating, we obtain, huh?
What is this?
We don't know what is the world temperature. We are saying let us define something called excess temperature. Excess temperature means it is what is the temperature above T infinity. This is local temperature. Is the temperature of the
Surrounding.
surroundings. This is convection. This is velocity, which is going here. Fine. This is the surrounding, right? Convection is happening. There might be a parabolic variation of velocity here. It is going 0 here and then it goes like this. Maybe there is a parabolic variation of velocity then, which induces a h, which induces a h, which is heat transfer coefficient. Makes sense? You understand what is h? It comes in Newton's law of cooling, where Q is equal to H A T infinity minus T infinity. Remember? Newton's law of cooling. Did not remember Newton's law of cooling? We said it here. Don't worry. See, is it not? Remember? It is Hc into A Tw minus T. Hc we have got as K by delta. You remember we said K by delta for Hc? Kf by delta. K of the fluid by delta will give us H. This is Newton's law of cooling. Correct? Don't worry. Nowadays, revising will become difficult. I know that. So I will do that revision part here only. So if you don't remember anything, please ask me. I will go back and show it because I know revision is not happening. I'm aware of it. Okay? You don't have time. I don't have time. But there's no other go. Had this revision be happened, then you will know it. But there's no time for that. I realize it. Okay? And you should realize that I also realize it. Now, so theta is T minus T infinity, right? So differentiating we obtain d theta, differentiating with respect to x, okay, d theta by dx is equal to dt by dx. Again differentiate because T infinity is constant. So when you differentiate, you get only dt by dx. T is the local temperature. Local as in anywhere.
Beyond the.
See, it is T infinity here.
Yeah.
Here T is equal to T infinite.
Beyond that,
No, here it is T is equal to T infinite, not beyond. T is that anywhere. It's a variable.
on the wall.
It's a wall also. T is the temperature. It can be in the wall, it can be in between wall, anywhere. Similar with this excess temperature. Can be anywhere. Make sense? I'll go slow, don't worry. To reduce the speed, if you think that I'm going fast, stop me. Ask me question. Even though it is stupid question, don't worry. Ask. Okay. That is, I will realize that it is going fast. I need continuous feedback from your side. Okay. How the feedback is, you are controlling. The speed of the class is controlled by you. Okay. So d theta by dx is equal to dt by dx. Okay. Now, again differentiating, we get d square theta by dx square is equal to d square t by dx. Now we'll substitute that here back. Make sense? This we are going to use a lot in fins. Don't think it is difficult, it's very easy. Fins are one of the easiest ones. And the question that comes, you'll laugh on that. After I do this, questions are so easy that comes in gate. Most of the questions you can solve just like that. I will show you afterwards how easy questions are. Done? What is V is velocity. So there is post convection, free convection, anything can be there. But because of that, there is a H which is happening. There might be a boundary layer which is generated here. That's what I'm saying. But we are not worried about why that particular H is coming, whether it is because free convection, whether it is because of forced convection. What is that? We are not worried. Okay. Next. Next one is this. Yeah. So therefore, we can write the heat conduction equation. Heat conduction equation in terms of the excess temperature theta as d square theta by dx square plus qg by k is equal to 0, or d square theta by dx square is equal to minus qg by k into x. Sorry, qg by k, right? Integrating again integrating we obtain theta is equal to minus qg by k into x square by 2 plus c1x plus c2. Now in the figure we have not set the coordinate system properly. Let us set the coordinate system. Once you write, I'll set the coordinate system back. Time is done, is it not? Few minutes. Huh? 8:05 I can do. You also, you people have bike, you can go. Right. Till 8:05, stop me now. I'll just explain this, then I'll stop. Done? Agacha, go slow, but go slow. Maybe you're showing off at that time, but now go slow. You're on record. I told him record only. Huh? No, no, no. He was little slow only. I'm just telling him. Did not go much fast. Next time I must. Huh? ನಮಸ್ಕಾರ ನಿಮ್ಮ ವಿಚಾರ ಗೊತ್ತಾಗಿದೆ ನನಗೆ ಗಾಳಿಯಲ್ಲಿ ಬಂದಿದೆ ಸುದ್ದಿ ಅಲ್ಲಿ ನೀವು ಬೈಕ್ ಇದೆ ಸರ್ ಬರ್ತೀರಾ ಅಂತ ಕೇಳಿದ್ರೆ ಇಲ್ಲಪ್ಪ ಕೆಲಸ ಇದೆ ಅಂತ ಹೇಳ್ತೀನಿ ಒಮ್ಮೊಮ್ಮೆ ಟ್ಯಾಲೆಂಟ್ ಅಂತ ಇರ್ತದೆ ಗೂಗಲ್ ಸರಿ ಈಗ let us put the coordinate system. Now let us put the coordinate system such a way that this is x and yeah, this is x. Okay, from here we are starting. This is 0x. Okay, that's nothing else. Okay, from there we are starting x, right? Now if you are starting x from this point, there is no y or anything. It's only x because we are talking about one dimensional heat equation, right? It's only x. So now if that is the case, the boundary conditions are the boundary conditions are at x is equal to 0, d theta by dx is equal to 0. Agree? Because it is a maximum. At maximum, d theta by dx is equal to 0. Correct? Next. This implies C1 is equal to 0. Correct? D theta by dx is equal to 0 means C1 is equal to 0. Correct? From here it comes. Right? Clear? Next. At x is equal to b by 2, d theta by dx is equal to minus qg by k into b by 2. Correct? Through this. Through this. Okay. Therefore, I'll write therefore, fine. Done. Now there is a important thing which has to be told. Okay, let us do that. Have you written this down? No. Now, done? No? Not done? Please write. Please. Here I am first. I have to be first. If I don't fast, I cannot sit here. Don't understand if I'm not fast. No, I cannot sit here. Correct? No? Now, here, very, very important. Okay, at the wall, yes, please. Huh? T will be anywhere. Which one? No, T can be anywhere. T is the temperature coordinate. At x, what is T? T is a function of x. X varies everywhere, not just from the wall. It varies outside also, in the fluid also. We are saying this is T infinity. There is heat generated inside. Huh. Or you can say this is like a heated iron, maybe. A heated iron from both sides. You can think about it. And there is air which is flowing. Air will also heat it up, is it not?
It will not be outside the
T will be higher than T infinity. Where T is outside T infinity. This is wall. This is T infinity. It is like this pump. So you understand? This is wall. From wall there is boundary layer, and then there is T infinity. Ask questions. Ask questions. Ask questions. More you ask questions, sometimes you will feel it is stupid, but it's very important. We had one of our students called Anirudh. He never understood. Okay, poor guy. Okay, poor guy in the sense. Otherwise, he's a rich guy, but in the sense that to understand, but very very innocent. Okay, he used to ask a lot of questions. Okay, some people used to show the face. They never said that. Oh, this is simple. Why are you asking? But because he asked those simple questions, there's a lot of things I went to the depth of. So even there should be one student who will not understand at that time and he asks stupid questions. And the way we are answering the stupid questions, based on that, there is much more insight that comes into the topic. You understand? So, done? Okay. Now, here, have you written that? Now, at the wall, at the wall, winter is coming. Okay. So, I've seen that, is it not? Okay. So, anyhow, at the wall, Q due to conduction, QK is equal to, this is heat transfer due to conduction. Heat transfer due to conduction is equal to minus K dou theta by dou theta by dou x b by 2. This equals K into Qg divided by K into b by 2, which is equal to Qg into b divided by 2. And that Qk is equal to H into heat transfer coefficient into Tw minus T infinity, which is actually equal to H into theta W, or theta W is equal to Qg into B divided by 2H. So we have arrived at the equation for the wall temperature, excess wall temperature. Make sense? Right? Oh, don't want this one. No, no equation. That's further we will see tomorrow. We'll stop it here. Further we will see tomorrow.
Sir, also QK is equal to H.
QK is equal to,
Also,
yeah, exactly. Also we can also not from here. It does not come from here. Right? Sure. Thank you.